For years, the solution has been messy. Write the easy stuff in Python and rewrite the performance critical stuff in C++ or CUDA. But what if you don't have to compromise? What if you could have the simplicity of the Python but the raw metal melting performance of the C++? Welcome to the Mojo. What is Mojo? So, what exactly is Mojo? Mojo is a new programming language developed by a company called Modular, and it's headed by some serious heavy hitters, including Chris Lattner, the guy who created the LLVM and the Swift programming language at Apple. The elevator pitch is simple. Mojo is designed to be the superset of Python. This means the ultimate goal is that any valid Python program should eventually run on Mojo. But Mojo adds a massive layer on top of Python designed specifically for systems programming and high performance AI hardware. It's not just another faster Python wrapper, it's a ground up rethink of how we build AI infrastructure. The problem Mojo solves. The two language issue. To understand why Mojo is such a big deal, we need to look at how AI is built today. We have what's called the two language problem. Take PyTorch or TensorFlow. You interact with them using nice, easy Python code. But under the hood, none of that is running in Python. It's all handing off the heavy lifting to the massive libraries written in C, C++, and CUDA, so it can actually utilize your GP. This fragmentation is a nightmare. It makes debugging hard, it makes deploying models complicated, and it means AI researchers often hit a wall where the Python skills can't take them any further down the stack. Mojo aims to be the single language that spans the entire gap from high level modeling all the way down to the low level kernel optimization. Okay, enough hype. How does it actually achieve this speed? Mojo gets its power from few key concepts. The first is progressive typing. You can write Mojo just like Python. It's dynamic, flexible, and easy. But when you need speed, Mojo lets you opt into strict type checking and memory management similar to Rust or C++. Notice the difference. In standard Python, we use a def. In Mojo, you can use a def, but for high performance, you switch to the F1. When you use F1, Mojo enforces a strict rules. It forces you to declare types, which allows the compiler to optimize the living daylights out of your code because it doesn't have to guess what data type it's dealing with at runtime. So, what does that actually look like in practice? When Modular was announced Mojo, they showed a demo calculating a mental throat set, a classic computationally heavy task. But Mojo was something like a 35,000 times faster than standard Python on a single CPU core. Now, take that with a grain of salt. That is a very specific math heavy benchmark designed to show off. You won't see 35,000x increase in your average the Django web server app. But for numerical processing, matrix multiplication, and the things that power AI, the difference is staggering. It's bringing GPU like parallel performance to the CPU. Okay, this sounds amazing. Why are we all using it right now? Because it's still very early. Mojo is not fully finished as of recording this video. It's not yet 100% compatible subset of Python. You can't just take your massive Django project, rename the files to .mojo and expect it to run instantly. Many standard Python libraries don't work seamlessly yet, and Mojo's own standard library is still growing. However, the team is moving incredibly fast. They recently released the Mojo SDK, so you can run it locally on a Linux on Mac. And the integration with existing Python code is getting better every month.